Okay. So I think we can start. So good afternoon, everyone. Welcome to this IBS Intelligence WebEx on artificial intelligence and big data. We're here to host two panelists. Mr. Ram Narasimhan, who's the global head of AI and cognitive services at Ziba, and also Ravi Subramanian, Senior Vice President and Head of Banking Practices for Hexaway Technologies. My name is Vincenzo Basilio. I'm a principal at Cedar Management Consulting for the FS practice. And I will lead you through this presentation. So the presentation will be basically structured in three pieces. So we have the first part, which will be my introduction. I will have a couple of slides regarding what artificial intelligence actually is, what big data is. So very academic slides. I will try to make them crisp so that nobody gets bored during the session. And then we will get into the application of AI in financial services and key technologies used. And also we will have a look at the key initiatives in GCC countries of AI and big data. So we'll move ahead. Okay. So when we talk about artificial intelligence and big data, let's introduce the concept. So before jumping into the straightforward definition, we can start putting some clarity around the idea of AI by dividing it into two high-level categories. So we have what is called general AI, also known as broad AI or strong AI, which is the idea of a machine that entirely fuses humans' ability to perform a wide variety of tasks, conduct generalized reasoning, applying common sense, and solving problems creatively. In essence, is what we see now only in science fiction. So I think we have still to wait a few decades to see it thoroughly applied to financial services and daily technologies. With respect to the second category, we get into the narrow AI. So narrow AI is instead the ability of addressing a highly specific problem, like for example, identifying an object in a photo or winning a chess game. Now, a good question that people may be thinking is, why does AI really matter? Well, if you think about it, even with most traditional computing techniques, no humans or group of humans could effectively analyze staggering volumes of data created every day and detect patterns, derive insights, and drive actions. So essentially, AI, it is the only tool at our disposal to do that. And this is not only for the sheer scale of data generated, but also due to the fact that such data is raw and unstructured. So giving some basic notions about what unstructured and structured data is. So when we look at unstructured data has no predefined model or organization. For instance, the millions of photos that are exchanged randomly, or the hours of conversations among stockbrokers, or also all those emails exchanged between servers are a typical example of unstructured data. When we go to structured data instead, structured data can be codified, it can be placed into spreadsheets, it can be sorted. For example, if you think about income statements or historical temperature or records of transactions, these are all examples of structured data. Now, going to an essential component in AI, well, we get into learning. So there are three major techniques of learning. The first one is supervised learning. What is supervised learning? Well, supervised learning, in essence, provides the model being trained with data that has been structured and labeled by humans, and where a clear objective has been defined, has been outlined. The second category is unsupervised learning. So training data has no preset instructions or labels set by humans, but allow the model to identify its structures, its patterns, and identify its groupings. Then we go into the third category of learning, which is reinforcement learning. Well, reinforcement learning scores the performance of variations in a model against an objective to determine which model works best for a given data set. So these are, in a nutshell, the three definitions of the key notions of learning. Okay. Now, when we get into now the definition of AI, well, AI in essence is nothing more than an umbrella term that encompasses many different approaches. We will see later, we have several techniques, machine learning, neural networks, genetic and evolutionary algorithms. And these approaches, they seek to achieve a wide array of specific goals. For example, again, identifying an object in a photo, translating a language, or predicting a behavior. When we go into big data itself is a field that studies the ways to analyze, extract information, or deal with data sets that are too large or complex to be dealt with traditional data processing application software. And hence, we can say that big data leverages AI techniques to do so. So this is, in a nutshell, what AI is, just to introduce the concept. So moving forward into the techniques of AI. Well, here is so there is no exact definitions about the clustering on how perfectly you can cluster the different AI techniques available on the market. Anyways, I attempted to classify them into three major blocks. The first one is machine learning. Machine learning is actually not new. I mean, we're hearing a lot nowadays about it, but that term is quite old. It dates back 1959 by Arthur Samuel. Samuel was a computer scientist. And what machine learning does in essence, machine learning parses existing data, learns insights from it, and makes a prediction based on that learning. So it is not a learning in the sense that a human being learns, but we can think it in the line of best fit in a sample regression model, which improves whenever a new data point is added. Now we go to the second one, neural networks, which sounds very fancy and complicated, but I will try to make it simple. So neural networks resembles the way a human brain works. So as neurons in the human brains are connected to each other via synapses, the process of an individual learning is a shifting of strength of the connections at those synapse points. So to put it simple, networks are constituted by three types of units. You got the input layer, which receives various data inputs with any type of structured and unstructured data, as explained earlier. Then we got the final one, which is the output layer, which provides the results such as predictions or decisions. And then we have the hidden units that typically provide layers of connectivity between input units and output units. So in essence, neural networks learn by reweighting the connections between artificial neurons. Then we go to the third and final one, and hopefully everyone has not fell asleep. The third point is genetic and evolutionary algorithms. So genetic and evolutionary algorithms apply the principles of evolution found in nature. So there are different models created, and only those that produce the best results survive. So in essence, a new generation of algorithms is created alongside the surviving ones, and this happened through mutations. So you mutate, adding new portions of the code being introduced, and the selection process is run again and again to produce a best of breed algorithm. So now I would say that the most immediate question that they would, or the most immediate comment that anyone would think after having thought about how complex these models can be would be, okay, so the best would be to have the most complex model to have the best result. Well, it's not exactly like that, because actually complexity raises two big concerns. And I explain you why. So first of all, we have resource constraints. As models complexity increase, so do the resources required to operate it. And there is a trade-off between marginal improvement in predictive result and increased cost in terms of resources. And we think in essence about electricity and human talents. And then we have also the black box effect. The black box effect, see, whenever a complexity increases in the model, it becomes difficult to get an understanding why a model resulted in a given output. And as you can imagine, this raises concerns, may raise concerns for a lot of financial regulators who need to understand what is the root cause of such a decision. Okay, so having said that, I am done with the academic introduction of the concepts of the AI, and I will move ahead talking about the key opportunities for financial institutions. So opportunities where AI technologies can provide benefit can be basically classified into 4 clusters, okay? So number 1, we have automation. So financial institutions can improve the speed and efficiency with which a process can be completed by reducing or altogether eliminating human intervention. So what happens is that this reduces in turn operational costs, may improve customer experience. Automation can be definitely enabled with RPA, which is robotic process automation, as long as inputs do not deviate from expectation. Then machine vision and advanced pattern recognition systems with self-learning capability can be deployed for more complex processes with more varied inputs. And then we get into customization. When we talk about customization, it is possible to receive highly customized financial products and services in, for example, in wealth management and wholesale banking, which are typically accessible to those able to pay higher fees as it typically requires human intervention. AI can break this paradigm, can break this trade-off, and enables personalized financial product at zero marginal cost once a system is in place. So think about a very easy example, the robo-advisors. Then we go into the third category, this the improved decision-making. So financial institutions can incorporate broader and less structured data sets into their analytics processes, enabling foresights. For example, by improving the ability to better understand how an uncertain situation will evolve, which can be seen writing a loan, insuring a car, or simply placing bets on the market next move. Then we'll get into the fourth category. The fourth category is about new value propositions. So financial institutions may find it is in possession of a unique set of data streams that place that financial institution in an advantageous position, either to deploy monetizable insights, such as more detailed macroeconomic reports, to suites of AI services that support automation, like customization and decision-making aims for other financial institutions. So artificial intelligence as such becomes an opportunity for financial institutions and themselves to provide other services to others. So moving to the next. Yeah. So moving to the applications of AI in subsectors of financial services. So definitely there is a massive application into lending. Why? First of all, because it's possible to it allows to reduce the cost of processing loan applications and improve the speed of loans deployment. Key technologies there used are natural language processing and machine vision. They support support verification of, for example, of prospective clients, clients documentation, accelerate KYC, and reduce fraud. The same technologies are also applied to support loans to small and mid-sized businesses. Work can enable the ingestion of non-standardized documents like financials. So this removes the need for manual processing and data analysis. Then underwriting models can improve decision-making around lending activities, for example, by including forward-looking indicators about a prospective borrower's ability to repay, potentially reducing the number of non-performing loans. But they can also increase the pool of potential customers by using alternative data signals to assess the creditworthiness wherever traditional credit agency data may not be available. So big data here supports with a range of new sources, such as bill payments, social media posts, shopping behaviors, which can be used by financial institutions to develop new models. Then also integrations with prospective borrowers' IT systems, such as accounting supply chain management system, can enable real-time data flows, which anticipate the lending need. Then going to wealth and asset management, natural language processing and machine vision can surely support faster client onboarding. RegTech firms can automate and streamline aspects of the compliance process. There are efforts to automate large portions of quantitative modeling processes that are central to the investment decisions for a fund manager. Then we got into insurance. Insurance claims processes to reduce costs and improve customer experience. Fraud investigation automation through automated patterns of potentially fraudulent activity, such as similar claims found by other individuals. And this frees up investigators to focus more on more complex aspects of their investigations. And again, we go to payments. In payments, we got compliance. So in compliance realm, AI comes into aid for financial institutions to abide by anti-money laundering and financial crime regulations. So machine learning can enable sophisticated algorithms that learn to recognize suspicious behavior and automate the process of identifying, scoring, triaging, and resolving alerts. And then we have data partnership. If you think about MasterCard and Google, they actually signed a few years ago partnerships where a stockpile of payment data purchased by Google allowed a trial subset of their advertiser to track when their online advertising leads to sale at physical location within the United States. So I'll go quickly in the interest of time, sorry, I was a bit long, to all the initiatives taken for AI and big data. So yeah, in the GCC countries, it's all GCC countries, Bahrain, KSA, they definitely, sorry, hold on. Sorry. So I was saying that Bahrain, KSA, UAE, they all had some initiatives both for AI and big data. So for example, Bahrain implemented the Bahrain 2030 vision. In big data, they had the open data strategy. KSA also had opened a new center for AI of energy. On big data, they launched large-scale cybersecurity initiative. Same for Qatar. The cabinets approved the establishment of a committee for Qatar artificial intelligence strategy. They started a task move program to enact Qatar as a leader of big data, and in the ICT area. And UAE, the launch of a strategy for AI aiming to create a virtual market with a high economic value. And also on the big data front, they launched a Smart Dubai initiative in partnership with IBM. So I'm done now. I will definitely switch on to the next presentation. Ram, over to you.
Yeah, thank you so much. Hi everyone. My name is Ram, and I take care of the AI and big data portfolio for Ziba Global Services. So today I'll spend next 10 to 15 minutes on some of the AI initiatives that we see the kind of trends that we see is emerging in the industry. And I'll also walk you through some of the case studies related to that. So in the next slide, in next 2 or 3 slides, we'll talk about what Ziba does as a firm, and following that, I'll just jump onto the trends and the kind of use cases and things like that. Yeah. So if you can move to the next slide. Yeah, if you can, yeah. So Ziba as a firm, we started operating in 2001. So we've been in industry for last 20 years. And predominantly, as you can see, with our global footprint, we've done exceedingly well in terms of market capitalization and in terms of working with different domains and different kinds of customers. We work with top 30 banking institutions globally, so we've done fairly well. And most of our top customers are banking customers at this stage. And we carry a niche in terms of launching digital banks as well. So that is also something, more than 2 or 3 projects that we've started in the last 6 months. So we've seen a great trend of adopting technology to a level where the entire bank can be launched in a matter of few weeks or months, and with all sorts of operations automated, with all sorts of reporting data being available in one place. And the scale of transactions, the performance of the transactions are also something that is sustainable. So that's the kind of competency that we bring in this area. So if we just go on to the next slide. So Ziba as a firm, we have 2 products at this stage, StackState and Instruct. StackState is an AI ops product. Instruct is a training product. We can definitely explain more about it when we talk in person or in a detailed meeting regarding that. But overall, Ziba as a firm, we provide technology consulting and engineering services related to Agile, DevOps, data, AI, architecture, testing, and things like that. Digital and enterprise being one of our strong focus area, where microservices-based solutions, application development, design thinking, software development, web app, all of those areas we cover end to end. And definitely cloud DevSecOps is something that we are champions when it comes to engineering. Data and AI, covering areas like data engineering, data science, reporting, data warehousing, AI, ML. So all of these areas we've kind of executed large-scale engineering projects. And quality assurance is another area where we excel, and we have our own solution as well called XAssure, which we kind of cater to our customers in terms of building an end-to-end testing portfolio platform for them, which is able to scale as per their enterprise needs. Lastly, we also have something called Ziba Academy, which does B2B, B2C trainings, and also has university programs, which can be, you can view it online. So this is the kind of portfolio that we carry. And we do have alliances. As you can see, some of the alliances listed here. These are some of the key alliances. We do have other alliances in place as well. Overall, if you see in the next slide, there are 6 core pillars for our engineering services center of excellence. One is Agile. Second one is digital enterprise that I spoke about. DevSecOps, when it comes to Kubernetes, Terraform, Docker, we're very good in that. Cloud services, all the 3 major providers that we're working with. Big data and data science is something that we specialize quite well and have tremendous amount of depth in it. And definitely, I think having the quality assurance aspect end to end, that is also a niche area. So when we work with our customers, we bring in this entire bandwagon of center of excellence, where there are dedicated teams and people and specialists who are able to come in and deliver it as a program. So that's about Ziba in a nutshell. Now we'll kind of go on to the BFSI trends and what we see in the industry and things like that. So one of the interesting trends that we see in the industry right now is around how and why a particular for example, a bank wants to implement AI. Basically, what they've seen is that there is a marked amount of improvement in competitiveness when they implement AI. And how do you think this is going to happen, right? Because for them, when they kind of think about technology or innovation, it is all about how do they expand the customer relationship, How do they actually improve their presence? How do they actually streamline their operations and things like that? Let's look at the next slide, which actually goes a little bit deeper. So what this says is that majority of the benefits are from mid office and from front office operations. And majority of the cost savings are coming where the backend office, which is around core banking or transactions being stored or analyzed and things like that, that is all fine. But then the entire integration and relationship to the front end, or communicating the information to the customer, communicating the information to the portals and things like that, that is something that could be optimized and automated further. And that is where a lot of innovation and investment is going in at this particular case in the industry as per research. And out of these things, in the next slide, you will be able to see that about 17 to 26%, the impact, majority of the impact is on customer engagement, right? The kind of relationship they are able to have with the customer, the kind of conversions they're able to have in terms of sales, in terms of product sales, conversion of product offerings, what is available for the customer, what information they can gather from the customer. That is the innovation, that AI innovation is able to help with and extract more information, which is in turn able to, push back a lot of other intelligence back to the system. And, the banking executives are able to take better information and, take a better decision based on the information and, utilize the technology. So in a nutshell, front office, mid office operations, improvement in customer engagement, these are the three areas where AI is having a significant impact. And majority of the cost savings from 2020 to 2023 is into these areas, and the investment is here. So that's what we see in the industry. So now let's look at some of the use cases, right? How do they actually achieve it? You can see here there are lots of use cases here, right? One related to KYC, sentiment analysis, NLP, NLG, and things like that. For example, let's combine call center agent matching with KYC and AML, for example, right? So if you take video KYC, where you're trying to provide a loan to a customer, or you're trying to activate a new account and things like that, it is a combination of organizing your agents to talk to your customers. On the other side, it is about recognizing the face of the customer, recognizing the identity card, recognizing the details related to the customer, combining them, processing them at speed in real time, and coming up with a successful verification, right? This entire journey has multiple AI solutions built into it, right? And it is also now possible to have this sort of a scale because of cloud as well, which is providing the scale and bandwidth to deliver complex solutions. So these are some of the use cases that are actually impacting the front office and the mid office operations. You can see with the previous implementation, you had to deal with the front end where you submit a form, you go to the office, you sign something, you talk to the branch manager, you come back. But here, it is all combined in one solution in a matter of 4 or 5 screens. So that's the level of sophistication AI is able to bring in. So if we just look at the next slide, now we spoke up, previously we spoke about the AI use cases. Now let us look at from a banking executive's perspective, right? I've just broken it down into 7 different layers: product offerings and pricing. So what happens here, if a customer is on online portal and they want to buy a credit card, or they want to buy a EMI scheme, or they want to go buy some loan, some gold, and they want to kind of buy some investment product and things like that, there has to be a digital workflow which actually allows them to do that. And on top of it, an engine which determines what is the right fees, what is the right pricing structure, which would be linked to this particular transaction or purpose. So that is one level of innovation a lot of people are actually focusing when they are thinking about customer acquisition, customer retention and things like that. This is one layer of entire program that they're investing in. Second one is around Salesforce enablement. Can you just go back? Yeah. Second one is around Salesforce enablement, where we are talking about smart portals, which showcases a lot of information related to a customer and the products together, and allows the relationship manager or the banking executive to take a call on the fly. Customer centricity, a lot of banks are investing on customer persona based products where they're able to see entire information related to deposits, wealth, investment, insurance, everything together in real time. So that gives them a lot of confidence and support. Payment solutions, as you can see, there is a lot of widespread fintech apps integration that is available. So a lot of banks are now opening up to the integration piece of it. At the same time, they're also doing their own transaction analytics, where they're getting down to the details of every transaction and trying to pick the intelligence from it so that they're able to sustain better in the marketplace. Digital solutions, where a lot of banks have invested already on virtual assistants, chatbots, and the subsequent NLP engine, which actually classifies, recognizes the context of data, and then triggers the backend forms and digital workflow to carry on the task, right? Fraud and security, what we see is that a lot of suspicious transaction analytics is being performed for internal systems. And a lot of models have been, apart from the business units, these are for the internal IT systems related to the users, approvals, and things like that. And obviously the fraud and risk related models are anyways in place. And there is also a lot of sophistication, a lot of investment into that as well. Regulatory wise, yeah, compliance automation is something that a lot of banks are actually focusing on. So these are the 7 top areas where we see we are also working with the banks, and they're also investing in terms of programs. So if you just go to the next slide, yeah. So a very quick overview of the use case that I just wanted to talk about. So this is about a bank where you have the contact center, you have AML rules, you have credit card applications going online, you have campaigns running. So there is a lot of information that is required for a particular customer, for a campaign, for a transaction, and this has to be supplied to the contact center at the right time, or to the fraud department or the audit department at the right time, forensic department and things like that. So we did a project with the customer where we built the backend data hub, and then we invested in terms of building these solutions: fraud detection, customer 360, predictive AML alerts and things like that. So from 30 days, 60 days, 3 weeks of reporting, it came down to hours and seconds of reporting. So that's the difference you're able to get with the adoption of technology. And at a large scale, you're able to process the information and get better results. So this is one of the scenarios and one of the use cases I wanted to explain. With the benefit of technology, you're able to kind of reduce the time required to analyze the transactions and at the same time take decisions in a much more faster manner. So this is another use case. This is around anomaly detection. So what happens when you're writing very complex models and when you're writing very complex statistics around it, sometimes the solution is not scalable. Sometimes there are a lot of false positives and things like that. So the entire logic was rewritten in machine learning time series algorithm, and the entire implementation with the accuracy was validated to reduce the false positives, right? So what I mean by that is, if there are 100,000 false positives and you have limited staff and you want to implement a solution, it's not possible to go and verify 100,000 transactions, right? So that is the beauty of bringing in AI or a technology advancement, where from 100,000 you are able to reduce it to 100 anomalies, which are to be investigated and to be, audited. So that is the level of sophistication AI can bring in to solve some of the problems in this area as well for banking sector. Lastly, in the next slide, You can see that the first solution, which is a scanner app. So if you're doing any sort of OCR application where you're extracting information for loan processing, things like that. So that is a cognitive services solution that can be built for a bank, loan processing, KYC, ID verification, and things like that. So that is something that we do for a lot of our customers. NLP engine for building a link between your transactions, customers, and brands. So that is also something that we have done for the banks. Data platform as a service on a multi-cloud environment, on an on-premise environment. We've done that sort of implementation as well. You know, customer loyalty, churn analytics is something that we do a lot for our existing customers in bank as well. Next best action, is something that we've done for a lot of banks at this stage. And there are at least about 3 or 4 other products that we've built for the banks. So if you're interested, feel free to contact us. More than happy to discuss that further. But I think overall, in a nutshell, I think NLP implementation, machine learning implementation for about 17 to 18 different use cases in bank, and building solutions at scale, that is something that the industry is definitely going towards. So with that, I'd like to conclude my presentation for today. Yeah, thank you.
No, look, thank you very much, Ram. Very, very interesting. Before jumping to the next presentation, I just wanted to share with you a couple of questions. So,
sure.
Honestly, I saw that the industry coverage provided by Ziba is truly impressive. So, have you experienced significant difference in the type of technologies requested across different industries? Do you have any example for that?
So I think majority of the times, if you think about it, banks have a very large spectrum. There is cards technology, there is core banking technology, there is SMS technology. So there are a lot of peripheral systems that the banks have to deal with. Then along with that, they also have to then build an aggregation engine in the backend, which holds the entire data set at a raw level, processes it, and then is able to do a real-time streaming for all sorts of customer offers, transaction alerts, etc., etc. So typically, a cloud implementation for a bank is something that is very scalable right now. Data center-wise, I think technology-wise, there is only few limited technology platforms that is available for on-premise, that is being around Cloudera, which is fantastic. And in terms of cloud, definitely Azure, AWS, GCP, all the 3 platforms are something that is preferred by majority of banking platform users.
Understood. Thank you. And the other question that was popping in my mind, right? What are actually the major constraints that you typically encounter when embarking into the implementation of any of your AI solutions?
Right. So as I said, when banks are dealing with multiple layers of solutions, right? There is core banking system that doesn't talk to a card system or some omni-channel system and things like that. The grain of information is at a different level in every system. So when you embark on an AI journey, you need to bring all those systems into a grain where it is easily readable, understandable, and can be linked together. So one of the constraints is access to those systems or relevant data set, and the preparation of the data for developing a ML-based model and getting that data set ready in a manner that we can actually solve the problem. That is something that takes time, and that is something that is not something that is easy. So that's what we've experienced. But yeah, I think availability and access to the system and data is something that is a problem sometimes.
Okay, thank you, Ram. Really interesting. Thank you very much. So I will move ahead. Ravi from Hexaway is now leading the stage. Please, Ravi, over to you.
Yeah, thanks, Vince, and thank you, Ram, and hello, everybody. I'm Ravi from Hexaway. We are a well-known brand. We've been in the business for about 30 years, but we call ourselves a billion-dollar startup. That's what we are. we will be closing $1 billion this year, and banking is very important part of that journey. And at Hexaway, there are 3 core principles which we believe in, which is automate everything, cloudify everything, and transform the customer experience. In everything that we do, we follow these 3 principles to the spirit of it. So yes, we've been fortunate enough to work with the large banks, the small banks, the mid-tier banks, and so on and so forth. And it's been very interesting today, right? What I heard from you, Vince, and then from Ram, about how AI and data and big data and all those technical terms that you were trying to explain at the beginning.
You didn't fall asleep meanwhile, because my concern is that possibly initially there was too much notions.
That took me back to my computer science class back in college. I wish some of my college buddies were listening to this. So yes, it's tough, right, to explain these things to people, and let alone explain how do you actually implement those things in real life, right? The beautiful results that Ram shared with us, right? That is possible, and it is possible. How do you actually start? If I were an IT leader at a bank, what do I do? Most banks already have most of the softwares that are required. They've already invested in some kind of automation and some kind of tools, and definitely they have a huge legacy of technology debt. That's the reality of the situation. How do we help them to actually leverage what they have in their real estate and exactly help them train the dragon, right? And help them fly. Like, how do you make their own data and the IT landscape actually make it a real asset, make it work for them? So we've been racking our brains at Hexaway within the banking team, and then discussing with several of our customers. Hey, you've invested X million dollars, you ran 3 transformation programs, and as Ram rightly said, core banking doesn't talk to omni-channel doesn't talk to cards, and so on and so forth. The problems still exist.
Yeah.
What do we do? And all these brilliant topics that Vince, you just told us, right? Deep learning, machine learning, and all that stuff. How do we actually bring it all together? How do we put a method to this madness and actually take it step by step and unravel this mystery? That's something that we actually, out of a personal need, and also after intense discussions and interactions with the leaders from the bank side, we've come up with a model which helps any bank actually to actually implement all that great stuff that you were saying in the beginning of this discussion and which Ram shared. So if you could go to the next slide, I would like to introduce to you a set of discrete 9 steps that we actually follow. It's we internally call it the butterfly, because just as an emperor butterfly requires 9 steps from being a caterpillar to be a full-fledged butterfly, this is how your data takes wings. And this is how AI can be brought into your operations inside your bank. And what do? It's irrespective of the tool, irrespective of the technology that you use. What happens is you need to organize your data in a particular format so that you can feed it to all these powerful tools that have come up. Because today, the art of the possible is humongous. So it's a 9-step process, and let me break it down, right? The first 5 steps are basically business-centric or domain context-centric. Then last 4 steps are extremely technology-intensive. So that's the real merger of the two. Now, what comes out of this, if I follow this nine steps in a bank? Well, I get to a point based on my maturity that I'm able to predict the business events based on the IT logs and traces that are there in my ecosystem. I'm able to connect everything in real time based on a business context. So based on my customer behavior, my consumer behavior, I'm able to connect the dots and predict the next action that the customer would require, rather than make the customer come to me and say, hey, can you give me this? Instead of I'm telling the banker in real time that Vince will need these 3 products in the next 2 quarters. I may be roughly right. I may be 60% wrong. No problem. But it doesn't hurt, because there are a lot of business intelligence systems out there and people have invested a lot in that'll do this. But all that is after the fact. Nobody does it before the fact. So these steps, let me just walk you through, take a few minutes and walk you through, is that the first is we need to get a context of the enterprise. What is that the bank is trying to do? And then have a wireframed version of the map, the enterprise map, which we call the GPS of the enterprise, wherein the business events and the IT transactions are connected. So every business event like account opening, customer onboarding, credit initiation, all these business events, what are the IT transactions which cuts across multiple IT platforms are associated with it? And what are the underlying technologies behind this? This mapping has to be there, which is what we call the GPS of the enterprise, or the maps, right? And once you have that, it's also known as better maps, BETR, better maps, that's how we call it. That gives that connect. Now, once you have that, you will have a deluge of information in any bank. That's our personal experience. We have to put the right level of signals, right levels of filters, and talk to the key stakeholders and say, hey, tell me your top 10 business transactions which keep you awake at night. Like if these things don't work, everything will go south. What are the top 10 things? Tell me that. And then we do the value mapping and the effort sizing for that. And then we bring in the IT Gin Bang, put in all the IT applications that Ram spoke about, all those technology stuff, identify the right tools. Every tool is great. Every tool is fit for purpose. So we have to identify the right tools for the right kind of level of granularity you need. And then once you do that, you start getting a bigger deluge of information. That is when the problem actually starts. You may think that you have solved the problem. That is when the problem actually starts. You know why? Because you have opened all the floodgates across the bank. Now, then what you do is, again, use this better map that you've got, and then funnel that information into the right pockets. So what happens is, you get to a point wherein you're able to connect your service level agreements to your operating level agreements, and your operating level agreements to your business level agreements, and business level agreements to an experience level agreements. Now, service level agreements are nothing but like systems have to be running all the time. They cannot, like, there has to be 5 nines and all that stuff. Everybody knows. And OLA would be right. If there are 6 hops in a bank to complete a process, we make it 2. And then when you get to a business level agreement, you say that customer onboarding, the abandon rate of my customer onboarding process should be less than 3% or less than 8%. If I'm sure any banker who is out there who's listening to this, they will just fall off the chair when I say 8% and 3%, because these are great numbers. When talking about when you go online, apply for a credit card, they ask you for a bunch of details. And then in the middle of it, you feel fatigued and then you leave. That's called abandonment. So that rate, how do I reduce that rate? And I sign up for that. I'll ensure that I will use the past transactions that customers have done in my IT landscape, use an AI engine to clean out the patterns and actually predict that a person with this demography, this background, and this persona is likely to abandon at this point. And hence, we need to fix this process proactively before it breaks down. That is what this model will help a bank achieve. And this works, this is product agnostic. This is a method which we have come up and successfully leveraged this across the board and helped our partners to realize the value that they were seeking. So those are the kind of things that we are looking at, and the art of the possible using artificial intelligence and data in the operations of a bank is what is actually I see the future in. While it's great to build a digital bank grounds up, it's great to transform existing applications from technology A to technology B. That's all exciting stuff. That always happens from time to time. But this helps you to leverage what you have already invested and get greater return. So the prediction is 4 out of 10 transactions going forward from 2022 are likely to follow a method or a model similar to this in any bank. That's the market spread and expectation for this. So that's something that we are extremely kicked about and based on our experience. Now, having said that, I've told you the method, how to do it. If I were a banker or an IT leader working in a bank, what are the first 5 or 6 things that I need to do in order to make myself ready to even implement this? If you could go to the next slide, you will see that there are some basic stuff that one needs to do in order to identify the hot buttons. As I said, if these 10 things don't work, everything will fall down. And then you invest in immersive analytics, which means you don't pull out a report and then try to figure out what is going wrong. The report should be generated automatically, analyzed, and the analytics coming out of that should be actionable. And the person or the persona who is responsible for acting on it gets that in their to-do list. So the problem is not only detected ahead of time, the fix is identified ahead of time by correlating historical information using AI and data. And then the person who is supposed to fix it could be a machine, it could be man. Don't know. That person gets that in the to-do list. This is what you need to start thinking about, because your ultimate objective, if you are a banker and if you're working in the IT department of a bank, you should always look at having continuous oversight. Because the way things are changing, the IT department is expected to advise the business, the bankers, saying that Mr. X was a very good credit score today, 3 quarters down the line, his credit score is likely to go down or maybe further up. You may want to right fit the products that you are putting in front of that person. So this continuous oversight is something we need to have based on the data which is available within the bank. So we've got a very interesting example, which is in the next slide. We've actually helped a bank out east, wherein we were able to provide a 360-degree view of the fund management in a single place using all these technologies, methods, and models that I've been talking to you about, and provide a great degree of data ownership to the bankers and provide them with a single source of truth. What happens is then the efficiency rate improved by just 30%, and the banker's satisfaction index just hit the roof. IT became a value center. It stopped being a cost center. So that's the serendipitous fallout of this whole model of actually bringing AI and data to life instead of just looking at them with wow and awe, saying that this is all tough stuff. So no, it is possible. It is doable. In fact, business areas like anti-financial crime, anti-money laundering, as Ram shared an example, right? It helped these technologies and methods and models helped another bank in Europe, wherein we were able to deliver them better business insights, and an efficiency rate was increased by 40%. And the biggest thing was the IT owner was able to predict what will go wrong or go right in the business over the next quarter. Every quarter they were able to predict, and they had a accuracy rate of 30% to 60%. That varies on the maturity of the landscape, but that is good enough, right? So that's to start, because we have just begun. The AI and data journey in banks has just begun. Well, thank you very much. Thank you. I enjoyed sharing my experience.
Win, yeah, you're on mute, Win.
Win, you're on mute.
Yeah, sorry. I did something wrong with the configurations here. You're able to listen to me now, right? To hear me?
Yes.
Yeah. So I was saying, so thanks. Very nice and interesting insights from both of you. I also have a question from you, Ravi. I was wondering, if you think about the data access. So data, in essence, is everything, right? When we thinking about our modules, the accuracy of your model actually depends on the amount of data that you can handle, right? So I was wondering, have you ever experienced any type of let's say regulatory constraints related to data access that would have limited the effectiveness of your AI solutions across the geographies where you implemented your solutions?
Definitely. What we normally do is we anonymize the data and then bubble it up, and we actually normalize it and map it to personas. That's the standard way of doing it, because there is a lot of non-public private information that is usually associated with banking, and banking has a lot of strict regulations. So it does impact, but then when we use patterns, right? We use patterns to overlay on that and try to make the data as useful as it can be. Well, the short answer to that question is yes. If you don't have any regulations, I can do much better. But then, if the data is not secure, I will not give my data to a bank, right? So it's a catch-22 thing.
Right. And I have an open question actually to both of you, Rama and Ravi. So in your machine learning solution, is there a specific type of learning for which you mainly use among the supervised, unsupervised, and reinforcement learning? I was wondering if yes, if there is any business or technical reason why to use one specific type of learning technique to another.
Ravi, you can go for it. Yeah.
Yeah, I'm sorry. Can you repeat the question, please, if you don't mind?
My question is very simple. It's just I was wondering. So we have different type of learning, right? In machine learning solutions. So I was wondering, do you have any type of learning that you prefer among others? So we've spoken about supervised, unsupervised, and reinforcement learning. Is there anything among the three of them that you usually use more in your systems, or do you in your solutions, or do you prefer them?
See, I'll go if it's okay with Ram. I'll go first. Now I get it. See, in a support kind of a situation, right, where I am responsible to run the bank, it is always supervised learning that is preferred, and then it gets added on to the intelligence, and then the patterns gets added, and the intelligence improves incrementally. That's a given. But then if you are doing something new, like for example, you are establishing a grounds up new bank and you're reimagining the whole thing, and you're like questioning, hey, why do we need private banking? Why? Questioning the basic principles. That is when you need this huge models that will run unsupervised learning. It will sneak into various other statistical models, give you the output, and in real time tell you what you're thinking is really useless or extremely path-breaking. So those are the kind of things. But in day-to-day, if you ask me, it's all supervised learning is something that is really useful in real life today.
Yeah. You agree, right?
Yeah. So what happens is there's always the kind of use case as well, right? So if there is a score, prediction, risk assessment, fraud detection, image classification, you use generally supervised. But when there is like millions of images, or they're trying to do something like a text mining on millions of banking transactions, or clustering or something like that, then maybe the data scientists will pick on supervised learning approach and things like that. Depends on the types of use case. But yeah, I think it's better to bet on the ones that is going to work for the bank.
Yeah, of course. Look, so I think we are already at the end of the webinar. I really want to thank you for the nice intervention, for the great insights you gave us. So what to say? Thank you. Do you have any specific questions furthermore to close the meeting? Because I think we can just wrap up. Okay.
I'm good.
Thank you very much and have a wonderful day.
Thank you. Thank you all. Yeah,
Thank you.
bye.